So let's just take a bit of time and talk about the graphs of functions and expressions and even circles. And let's see if we can just figure out if there's something about the way they're written, the form that they're in, that helps us decide what the basic shape is. And obviously you can always use an XY table or just plug in points, but this will give us an idea conceptually of what we're looking at, what kind of graph we're dealing with from the beginning. Okay, so how do you know if you have something that is linear or is a line? Okay, a couple of key things. There's two forms that I've given you here. Y equal mx plus b. We call this slope-intercept form, and you'll learn that when you do a lot with lines. And we have maybe a form like this, ax plus by equals c. This is called standard form. Notice the x and y are on the same side, and the coefficients a and b don't have to be 1. So there are, maybe other forms to write lines. We have one that's called point slope, but it's actually, when you simplify, you get one of these. So this is just in general. The biggest indication that you're actually dealing with a line really isn't if it's in this form or this form. A couple of key things. First off, the powers, the exponents of x and y are both 1. So notice x to the 1, y to the 1, x to the 1, y to the 1. You're talking about a line. There's no other powers of x or y. You can definitely have constants, and you can have coefficients that don't have to be 1. So m can have different things in here. If you have a positive slope, the graph looks basic shape is something like this. A negative slope is something like this. And if you have y equals c, slope is 0. We have a constant. So one thing to point out is if you're looking at slope, positive or negative, it is useful to look at y equal mx plus b. Y equals some positive number times x plus some other number. And here maybe y equals some negative number times x plus some other number. That's when you can really just quickly look at the form and identify what your slope is. It's a little harder if it's in a different form, but you can always get it to look like that. We'll talk about that when we do some examples. Okay, how do you know when you're dealing with a parabola? Okay, a lot of teachers will say, oh, this is quadratic, and you'll be going, well, how do you know? Well, in general, we have the form y equal ax squared plus bx plus c to represent a parabola or something that is quadratic, but maybe it's not given to you in this form. Maybe things are all mixed up. A couple key things. The highest power of x is 2, so you look at the exponent. The exponent here is 2 for the highest power of x. Okay, and you may have x to the first power, but it's not necessary. You may not. Okay, and then we only have one y, and it's to the first power. Notice in this form I've given you y is to the left and everything else is to the right. That doesn't have to be the case. It could all be mixed in, but you're looking at y is to the first power. And there's no mingling of x's and y's, no term that has x and y multiplied together. No fractional powers of x or y. Sometimes instead of fractional, you may see the word rational. No rational powers. That's the reason I wrote fractional, is I want to be clear that I have some number over some other number. You can have constants mixed in, and you can have coefficients, but the biggest thing is confirm the powers of x's and y's. So the biggest thing is you check the powers. Notice here this is x to the 0, x to the 1, x to the 2. Those are the only powers you can have for x, and y can be to the first. Okay, if the coefficient of x squared is 1, and it's written in this form where y is on one side and all the x stuff is on the other side, and the coefficient of x squared is positive, then it's a parabola. It opens up. If you're happy, you're positive. Okay, and if the coefficient of x is negative, if you're negative, you're sad. So it's another way of thinking about it. Okay, so let's do a few more. Absolute value. Now, where things will get more complicated, the more math you learn. That's always fun. But probably when you first learn about absolute value, you're going to look at something that looks like this. And I want to really stress, this is y equals absolute value of something that is linear. Okay, so notice, look very, very, very carefully. Mx to the first power plus b. Inside the absolute value bars, delimiter is what we call it, but inside those bars, the highest power of x is 1. If it's not, you're dealing with something else. Okay, so if you have something linear, highest power of x is 1 inside those absolute value bars, then you probably got a v, the absolute value shape. Notice y is over here on the left all by itself. It's to the first power. You can have constants and coefficients of x inside the absolute value bars, okay, but it has to be linear. X has to be to the first power only, okay? Now, no fractional powers either. This makes a V. It opens up if there is a plus outside of that absolute value bar. Okay, so y equals 2 times 3x plus 5 in absolute value opens up. Would open down. So it doesn't just have to be a negative, it has to be a negative number or a positive number. The coefficient of the absolute value is positive or negative. It tells you which direction it opens. Okay, then we have a square root. Again, look under the root. We talk about the anatomy of a root. This is called the radical. This is the index right here. And what is underneath is called the radicand. Okay, so notice we have y of all by itself to the left. Y to the first power equals this root. And again, look, y equals the square root of something linear. X is to the first power. Okay, and we'll talk as you start doing transformations later in your math courses about different things. The coefficient of x could be negative and what happens, but as a general rule, right now we're going to talk about just if it's positive. But the power is positive 1. You may have constants in the radicand. Coefficients don't have to be 1. The basic shape, if the coefficient of x is positive, is like this. Notice this is y equals positive square root of some positive number times x plus some other number. And this is y equal a negative times some positive number, x plus a number under the root. Okay, so we can, this is the original square root. And if we multiply by a -1, you are reflecting it across the axis. Okay, so when you start doing transformations, you'll see what happens if you multiply x by a negative, what happens there, but let's just do this basic shape for now. Let's do a few more. We have cubics. Now notice, again, this is in a nice form. Everything is in order, looks very neat. Y all by itself to the left, y to the 1 equals ax cubed plus bx squared plus cx plus d. If it's in this form, then maybe you remember it's cubic, but it could all be mixed up. So what do? You check. You start looking for the exponents. It says there's only one y, and it's raised to the first power. The exponent is 1. The highest power of x is 3. You could have an x squared, an x term, and a constant term, but the highest power of x is 3. There's no fractional powers. You could have constants. You could have different coefficients. Okay, but the biggest thing you check are the powers, the exponents of the highest power of x and the y term. Basic shape goes like this or like this. If the coefficient of x cubed is positive, it looks like this. Now you might see it more exaggerated depending what's happening to these middle values, or maybe even less exaggerated. Okay, but the basic shape is kind of like this. Okay. And then this is not a function. Maybe you don't even know what a function is right now, but you can talk about something called functions. This is a circle, definitely not a function. I just wanted to really talk about this one because sometimes this shows up and people aren't aware. The highest power of x and y is 2. So there's an x squared and there's a y squared. Another thing that has to happen if you have a circle is the coefficients of x squared and y squared must be the same. There are a few other things that must happen if you have a circle, but again, when you start talking about circles, you'll learn a little more math and you'll know what those are. But for now, this is just the very basic. First thing you check is you check the powers. Highest power of x and y is 2. You can also have some constants and some other stuff, but then you say, well, the coefficients of x squared and y squared are the same. No fractional powers. Okay? So let's do some examples. All we really care about right now, the whole purpose of this video is just to show you what basic shapes are, help you become familiar. So if your teacher starts talking about, we're going to do something to this expression, or we have an equation that looks like this, hopefully you can recognize some of these properties and say, oh, I know if I were to graph that, it would look like a line or a parabola or a square root function. Okay, so that's the purpose of this video. You obviously can always use an XY table or some sort of graphing program or software to get the exact shape. We will know the basic shape so we understand some of what the properties